Hi, this is Christina, and today I'm going to quickly go through the 8 common things I see people do to catastrophically destroy their cloud-native architecture. And these are just my 2 cents, and I would love to hear your feedback in the comment section below. Let me know. So the first one I see is making the bounded context wrong. Right? So what happens now is that when you created your first microservices, you decided what you want to do with it, and then the more you think of it, the more feedback you got, the more you change your microservices, and then you end up with something that's totally different from what you kind of designed it, what you started with. And the problem with that is sometimes when you put it back into your system or in your entire architecture, you'll find there's a lot of dependencies and stickiness to this particular microservices. And the worst thing is every single one of microservices end up doing the same thing. And then you will have a very complicated dependency with each other that makes the maintenance very hard to do and the scaling up and down very complicated. That's not a good sign. The other common symptom that I see when people make mistakes when doing bounded contexts is that they will create a single microservices or a single object that has been used in many different bounded contexts, and they're all sharing the same kind of source code because this is one of the core business, so they cannot get rid of it. And then slowly they kind of find that there's going to be a tweak in between different bounded contexts, so they end up maintaining a bunch of different small changes of the source code, and they end up being everywhere. So that is also not a good sign. So to get rid of that problem, it's time to step back and then go back to the design phase and think about the bounded context again. Are you making sure that the objects are correctly identified? Are you sure they're sharing the same thing, or is it should be shared among APIs, or they belong to other bounded contexts? It shouldn't be in this one, or you're putting just way too much. What I mean is that there's 2 main responsibility of microservices. The first one being the functional core business microservices, which is what people normally talk about when they think about microservices, which is doing a single function and then perform it well, right? So, but there's a second category of microservices, which is called composition of microservices, which is responsible for just doing orchestration or composition of different microservices. That takes away the burden of connecting to each other and then having microservices being too sticky to each other. Again, stickiness is one of the things I found that people make mistakes. And within the composition microservices, there's 2 different kinds: a stateless type of composition and a stateful type of orchestration, right? So if you mix them up into one single microservices, you'll end up with a very complex and hard to debug relationship between each other. And then you'll have your spaghetti code or your spaghetti microservices because they're all distributed in different environments. So you need to try to call them either using APIs or events or whatever they're using, and they're too much coupled to each other, then you're kind of stuck in another monolithic or dependency hell again. So having a clear responsibility for your microservices is super important. So one of the way that you can do is make sure that you have your core business microservices done, and then having some of microservices being responsible for putting things together and having them into different categories. And in this composition of microservice category, you can do a lot of things like transformations, aggregations, orchestration, and then connecting to internal resources. This is kind of our traditional way of dealing with integration, but in a cloud-native world, we kind of don't do that anymore. We kind of have this responsibility in this particular category of microservices, and having enterprise integration pattern apply there can help you a lot when you're trying to put things together in the less coupling ways. So the third thing is to let the clients consuming your services knowing too much about your microservices. For instance, for them to call every single one of the microservices that's available inside a bounded context, I think that's giving out too much details. And when you're trying to update anything, it's going to be a very complex process because sometimes you need to let your clients know, and then your clients need to make changes according to what you've done. And then versioning can be a big problem as well, because sometimes one client needs to update one of the microservices there and the other client doesn't, and then it becomes a very messy kind of managing type of scenario, something that you don't want to get into, right? So that's the third thing. And the fourth way is duplicating and replicating non-business code in the microservices. I think we all know that we don't want to duplicate our code. So why are you doing this in your microservice as well? For instance, circuit breaking is one of the very popular scenarios that we have in microservices, where people tend to put circuit breaking rules inside the application. You don't want your developer to hard code the rules, all the circuit breaking rules like timeouts or retried in every single microservices. You want them to be centralized and then managed all together, and then hopefully separated, and then having some of the people that has network access or monitoring rights to update all those kind of things, right? So that's another thing, is don't duplicate your code, especially the networking type of especially the networking control or the retries kind of things. You want it to be out of your microservices. The fifth one comes from the early adapters of the microservices, where they tend to connect most of the microservices with RESTful calls, or sometimes they call it APIs. There's no problem with RESTful call. It's very simple to use, and most of the libraries or languages supports simple HTTP calls. Well, there's a problem, because when you're trying to connect a lot of, or a chain of microservices together, what happens if one of the spot in the chain reacts really slow? And when you're trying to communicate to multiple systems, then you have to make multiple calls, and then you have to deal with a bunch of threads. Then you're adding another complexity to your app, which is not very ideal. The way that you have to wait for request and response, and because of that, you're not utilizing the cloud infrastructure. So people are now using event-driven architecture, which is pretty good. But one of the common problems I see is that people don't often sort the events. So you have a blast of events everywhere in your system, and then you end up having to write an extra filter in your microservices to filter out the events that you don't want to react upon, which is not very ideal. And then there's another problem of, because there are different sorts of events, sometimes you need to preserve them, sometimes it's fire and forget, and there's different technology that is better for different scenarios, and people are picking and choose wrong type of technology to deal with all these events or messages. To avoid that, try to think about events. There are different type of events: the status updates events, the data events, where you have the data of the message you wanted to transmit from one place to the other. There's other things like commands and all that. So make sure that you sort of different events, and then you can figure out what do I want to do with them. For the data messages, but before I send it off to them, I want to do some filtering so I don't send off a bunch of unwanted data into their system, so they have to do another processes. So different things you can do. I'll talk into that into my other videos if I have time. The other common problem I see is that people are creating a lot more data silos. Coming from a microservices purist type of view, they would say you will have one data source per microservices. And because of the distributed nature of microservices, now it's much more harder to get the consistency of the data. And some of the things I see is that people are creating another microservices just to sync up the status in between data sources. And then otherwise you would have people sending off status events everywhere so that the data are synced. One of the strategies that you can take is to capture the data changes to your data source. So if there's any change to the data source, there will be events populating to the necessary data source and making sure the data are consistent. So coming up to the last problem is automations. And this I see all the time, where a developer, they just went off and created a bunch of microservices, and they were all deployed onto this cloud native environment where everything is distributed. But the thing is, they don't have the right automation done. So that becomes a big problem, where people are now have to do a lot more manual work. Instead of just deploying one single monolithic application, now they have to deal with hundreds or thousands of microservices, which makes operation a lot more harder. So make sure that you define your automation strategy before you go off and then create your microservices. So these are just my 2 cents on the common things that people do to destroy their cloud native application architecture. Please leave your comments below and let me know what else would people do. Love to hear from you. Thank you.